So what we're going to be looking at today and Thursday, we're going to split this up across 2 days. We'll do something different tomorrow. We're looking at inverse functions. Inverse functions. Yes. Yes. And if you miss it tomorrow morning, you're going to have to take it Thursday. And if you miss it either one of those days, they're going to pull you in and make you take it. There is no avoiding this test. Yep. So what we're looking at today is inverse functions. Now, inverse functions, if it has an inverse, it will pass the horizontal line test. So if you draw a horizontal line through the graph, it will only pass it once. If it crosses it more than once, like this one here, it does not have an inverse as the function stands. Now, we can make it so that it does have an inverse by putting restrictions on it. Talking about x is greater than or equal to 0, we're only talking about the positive side of the function, or only half of it. So it is possible, but we have to put restrictions on it. So what we're going to do here first is finding the inverse of a function. Now, I don't really like how the book does this, but it is part of the assignment, or kind of the assignment in working with it. It's still the same thing as finding an inverse. It's just a little bit different, and we'll see that here in a minute. But what we want to do first is we want to solve y equals f of x for x. And really what we're going to do first is we're just replacing f of x with y. So y equals 2x plus 3. Because that's all it's saying, y equals f of x. So y is f of x. So we can really rewrite it. Instead of having f of x, we have y. And what we want to do is we want to solve it for x. We want to get x by itself. So what would be the first thing we need to do in getting x by itself? Subtract 3 from both sides. And we subtract 3 from both sides, we get y minus 3 is equal to 2x. And then we would divide by 2. One more page. And we would get x is equal to y minus 3 over 2. That's it. We solved it for x. Make sure this starts recording again. But on the assignment, when it asks for solve y equals f of x for x, it's going to want it in this form here. It's not going to want it as y equals x minus 3 over 2. It's going to count it wrong, because I think at this point y'all have noticed on the assignments, if it has it in terms of x and for some reason you put it in terms of y, well, it's normally the other way around. They have it in terms of y and you put it in terms of x. It counts it wrong because it's in x instead of y. I have a feeling y'all have had that happen at least once on those assignments. So that's why I'm showing you this here, because it's the same steps and the same process that we will use to find the inverse. It's just that the variables are flipped from what we would do for inverses. So any questions on this here so far? But we do have the other part of it, which is asking us to find the input when the output is -7. Well, in this equation here, x is always the input. It's the values that we plug into the function. Y is the output. It's what comes out. So if I know the output is -7, what it's telling me for this equation is y is -7. I want to find out what x is. Well, -7 minus 3 is negative. And -10 divided by 2 is -5. So on a whole, with this input and output, what it's telling me is the input values, well, -5, only take f of x. If I plug -5 in for x, we'll get -7 out. That's just how the functions work for this here. We plug -5 in, it'll tell us that it's -7. And what we'll eventually get at is the inverse of x will be a function that takes the output and gives us the input back, like we just got. We plugged the output in, it gave us the input. That is what an inverse does. Inverse function does. Well, let's look at another one here. Go on and grab that. We're on problem number 2. Yes. We got one right there. All right, guys. So looking at this here, the first thing we're going to really want to do for solve y equals f of x or x is we need to really replace f of x with y. So we're going to start off with setting this up as y equals 3x minus 5. And we want to solve it for x, so we're going to get x by itself. Well, the first thing we can do in getting x by itself, we can add 5 to both sides. If we add by the 5 to both sides, we have y plus 5 equals 3x. And then divide both sides by 3. We get x is equal to plus 5 divided by 3. And we've solved it for x. Now again, the next part is find the input when the output is -11. Well, x is our input. It's the values that we plug into the function. Normally, x was going to be the input, and y is the output. So if I know the output is -11, we can plug it in as -11 plus 5 divided by 3, because that will give us what the input is when the output is -11. Well, -11 plus 5 would be -6. Well, -6 divided by 3 is -2. And that is it. That's all we have to do for this here. Any questions on this here so far? All right. This one here is actually not that bad. Well, we start off with what? Y equals so what would we do first? Yep, add 2 to both sides. Tells us x is equal to y plus 2. What do we do next? Yeah, because that's already by itself. X is by itself. There's nothing else we need to do with it. So now we can use this to find the input when the output is 2. Well, 2 plus 2 is 4. Questions on this here? Okay. Now this one here technically does not have an inverse, but this one here will fail the horizontal line test. Because if we can draw a horizontal line across its graph and it crosses more than once, it does not have an inverse. So this here would technically fail it, but we're going to go on and solve it anyways. Y is equal to 2x squared. So what would we need to do first? I would divide first. Because square roots are roots, I would always wait till the end or wait till I absolutely have to do it. So we want to wait till do those. Because if we did take the square root of both sides first, I'll do that over here. Well, we can do that. But if we do this here, we'll end up with plus or minus the square root of y is equal to the square root of 2x squared. Now we've got to break those apart and then divide both sides by the square root of 2. So there's nothing wrong with doing that. It's a little bit more funkier and kind of clunkier to work with because now we've got square roots and we have to deal with the properties of them. So if, instead of doing that, we do divide both sides by 2, we end up getting y over 2 is equal to x squared, which would give us the exact same thing, because we'll end up getting to the same place. Because at this point here, then we would square root both sides, because the square root and square will cancel, leaving us with x is equal to plus or minus the square root of y over 2 . Now again, we need the plus or minus because when we square root or take an even root of both sides, we do need the plus or minus. And this would be it. Now this is different than when we put both sides to an even power. Because if we put both sides to an even power, we don't need the plus or minus. Because anything inside of a root, a square root, the square root of x has to be positive. Because if we're taking the square root of x, it has to come out positive. So if I square it, it's going to be positive anyways. So we don't have to worry when we square both sides of the positive or negative. But when we're taking the square root, what goes inside of x can be positive or negative. Because when it's squared, it can be positive or negative. But when we take the square root, it has to be positive. So there's a slight difference between those two. Any questions on how we got x is equal to plus or minus the square root of y over 2? Well, now we need to plug it in and find out the output when the input is 2. Well, 2 divided by 2 is 1. And the square root of 1 is 1. Any question of everything we've done so far? We're good with this here so far? Okay. All right, now we're going to look at a cubic. A cubic. Now, for most cubics in this form, where we don't have a quadratic term or a linear term, where we don't have an x squared or x term, most of these here where we just have x to the third and a constant or a number, they're going to have inverses. Not all cubics are going to have inverses, because you will have some cubic functions that will look like this here, where it will not pass the horizontal line test, because there will be spots where it crosses here 3 times. But this function here, if we actually looked at the graph of it, 1, 2, 3, at -3, it is going to be doing this here. Now at -3, it's going to get close to being a spot where it crosses more than once, but it actually never does. So this function here does have an inverse. And we could find it, or we're just going to go about doing the same thing we've been doing. Y equals -x cubed plus 3. And we're going to solve this for x. Now, based off the last one we did, we know that this one should have a what? Or when we get x by itself, a cubed root. We're going to have to use a cubed root eventually, yes? So the reason I bring that up is, well, in reference to the ACT today, and the ones that are in the ACT class are going to know where I'm headed with this, be looking at the answer choices. Because if we're finding the inverse of this and it asks us to find the inverse of -x cubed plus 3, well, if any of the answer choices don't have a cubed root, because we know we're going to need a cubed root, those answer choices are gone. They don't work. Because it's kind of helping us out. We also know that the 3 is going to stick around most likely, yes? So any ones that don't have a cubed root of 3, those are gone. They can't be it. And that's helpful and nice because, well, have we actually done any mathematical steps to eliminate those answer choices? Well, no, we're just looking at the problem. That can be very helpful, especially on a timed test. Now, if we did go through and get x by itself, what would we do first? Subtract 3. Because these will cancel. Now, what can we do next? Yes. How can we get rid of the negative? We can divide by -1. Now, when we divide everything by -1, well, the x cubed, -x cubed, is going to become x cubed. What's going to happen to the y minus 3? The signs will flip. So y goes from positive to negative, and the 3 goes from negative to positive. Now, again, this would be, if I was taking the ACT at this point here, I would have actually gotten my answer choice. I'd be done. Because I know what would be the next step. Cubed root both sides, yes? On an ACT or standardized test, it just matters getting the correct answer. So does it matter that I write down the next step of cubed rooting both sides? Well, no, they're not going to check my work. They're just going to check the bubble sheet that I submit, yes? So at this point here, I would select the correct answer because we're pretty much done and move on. Does that make sense? So sometimes, especially once you get it eliminated down to the one answer, select it and move on. But here, unlike the ACT, we have to finish the problem out, taking the cubed root of both sides. Well, these would cancel, leaving me with x is equal to... No,
it's not plus or minus.
It's not that the y is negative, it is we have a cubed root. Yes. With even roots, we need the plus or minus. With odd roots, we do not. And that's even a good thing to look out for. So if you know in solving a problem or getting a variable like this by itself, and we have to use a square root, having plus or minus in those is important. We need it. And it does ask for the output, or the input when the output is 2. So we got to plug 2 in for the output to figure out what the input, the corresponding input for it is here. Now at this point here, I would just type this into the calculator and see what it gives you. So you can just type in the cubed root of -2 plus 3 into the calculator. And most of these here, it's going to be, it might be easier to type them into the calculator. Some of them might be easier, or if you find it easier to do it by hand, do it by hand. Well, what is -2 plus 3? 1. The cubed root of 1 is 1. This would give us the cubed root, -2 plus 3. 1. So x is equal to 1. And that's it for that one there. Questions on this here? Okay. Now this here is actually finding inverses. So this here is going to be a little bit, I mean slightly, it's only going to be like we flipped one thing, is really going to be the only difference from what we're going to do for actually finding the inverse and what we were doing for y equals f of x solve for x. Now our first step is going to be just the same. We're going to rewrite f of x as y. That's going to be the first step in finding an inverse. We're going to rewrite f of x as y. Step number 2, switch x and y. We good so far? Hopefully. I mean, we haven't done too much, yes? We only rewrote f of x as y, switched x and y. Okay, get y by itself. So what do we do first? Add 1 to both sides, which would tell us that x plus 1 equals 3y. Then divide both sides by 3, which would tell us y is equal to x plus 1 divided by 3, yes? And on the ones we did before this, this is where we were done, yes? Because we got x by itself, we were finished. But there's one additional step, okay? So are there any questions on how we got to this point here before we do the last step? Now the last step for inverses is we have to replace y with f inverse of x. So when you see this here, f -1 in the exponent, kind of an exponential form, x, it's saying f inverse of x. This is the inverse function of f of x. Because our f of x was 3x minus 1. Its inverse is x plus 1 divided by 3. Questions on this here? So it's not too much different than what we were doing. We just kind of flipped the variables. All right. Let's go on and do this one here. So what would we do first? Yes. Yes. by? Yes. F of x, yes, equals x over 2. Any questions on this here so far? Okay. I'm not going to bother with negative, what is it? Negative x plus 1. I think y'all have got that. Yes. Let's look at this one here because it gets a little tricky with the 1/3. Not too bad, just a little bit. So we would have y equals 1/3 x minus 2. Then we'd have x is equal to 1/3 y minus 2. And then what would we do next? Yes, I would agree. Let's add the 2. Add 2 to both sides. And then what? Yes, this is exactly why I wanted to pick this problem here. Because we're very used to dividing by 1/3. Yes? And mostly, especially in Algebra 1 and Geometry, when we divide both sides by 1/3, it works out nicely. Here, not so much. Because if we do divide by 1/3, we'd get x plus 2 over 1/3 is equal to y. Well, in our last section or chapter with rational functions, well, we had a lot of parts of it talking about the fact we cannot have a fraction inside of a fraction, yes? So we would have to simplify that, and that's not too bad. But what we can do is we can actually use multiplication. And I can multiply it by its reciprocal. And the reciprocal of 1/3 is 3. Because the reciprocal is the flip. Because 3 times 1/3 would actually give me y. Because 3 times 1/3 is 1. So these here will simplify. And what I do to one side, I have to do to the other. Well, 3 times x is 3x. 3 times 2 is plus 6, which tells me that f inverse of x is equal to 3x plus 6. Bless you. Bless you. So questions on this here. Now I'm going to still show you this over here. Because when we divide both sides by 1/3, really we're saying x plus 2 divided by 1/3, yes? Well, for me to do the division, I've got to rewrite, I change it from a division to multiplication, and multiply it by 3, which would give us 3x plus 6. So the reason, it's not that this is wrong. There's nothing wrong with this here. It's a way that works. But we added 2 extra steps into solving it. It's a lot easier, especially if this wasn't x plus 2. If this had just been 2, then dividing by 1/3 is fine because I can type in a calculator 2 divided by 1/3, hit enter, it gives me the answer. But because of the x, it makes it harder to divide by 1/3, and it's a lot easier to just multiply by 3, which we end up having to do anyways with our division of a fraction. Now, it does work out if we had 2/3 instead of 1/3, we would have just multiplied everything by 3/2, because we can flip it and multiply just fine. Any questions on this here? Okay. How are we feeling with these inverses so far? We feel good with these here? Find the inverse of f of x equals x squared, then graph its function and its inverse. This is where we're going to stop with the notes for today. But since we do have a little bit extra time, we're going to do something